If you've ever heard quantum computing and immediately pictured Doctor Strange doing algebra in a wormhole, same. But quantum computers aren't magic. They're just wildly powerful machines that use the strange rules of quantum physics to do things classical computers can't. Quantum computing is a type of computing that uses qubits, which can exist in multiple states at once thanks to quantum superposition, allowing massive parallelism in processing. Why is that a big deal? Because problems that would take your laptop longer than the age of the universe to solve, a quantum computer might solve over a coffee break. Things like simulating molecules, cracking encryption, or designing drugs out of thin air. Normal computers use bits, those familiar ones and zeros. It's binary, like a light switch, on or off. Quantum computers use qubits, which are like moody teenagers. They can be 0, 1, or both at the same time. And there's more. Qubits can get entangled. Quantum entanglement is a phenomenon where two qubits become linked, so their states depend on each other, even across galaxies. It's basically what happens to one instantly affects the other, no matter the distance. There's just one catch. Quantum computers are absurdly sensitive, like cries during dog food commercials sensitive. Tiny errors in controlling a qubit can wreck an entire calculation. To work properly, quantum computers need quantum logic gates. These are operations that change a qubit state, like flipping or entangling it. Think of them as the quantum version of classical logic gates, encoding, like and, or not. These operations manipulate qubits to be almost perfectly accurate. If you mess up even one operation in millions, the whole answer could be trash. That's why today's big headline matters. Researchers at the University of Oxford just built a single qubit operation so precise it only makes a mistake once every 6.7 million tries. Error rate is the likelihood that a quantum gate messes up, so lower is better. Oxford's new error rate is 0.000015%. To put it in perspective, you're more likely to be struck by lightning than for this gate to mess up. That's insane. So, how did they do it? Most labs control qubits with lasers, fancy but finicky. Oxford ditched the light show and used microwave signals to control calcium ions trapped in a chip. This ion trap is just a device that holds charged atoms, or ions, still using electromagnetic fields. The calcium ion was an atom missing electrons used here as a stable, controllable qubit. Microwave control was using electronic signals instead of lasers to manipulate qubits. Microwaves are not only more stable, they're easier to integrate into chips, work at room temperature, and don't need expensive magnetic shielding. That's a huge win for scalability. This record-breaking precision isn't just flexing for physics clout. It means we need fewer qubits for quantum error correction, which is currently the biggest obstacle to real-world quantum computing. Quantum error correction is just a method to fix errors in quantum computation. It needs lots of extra qubits if your gates aren't precise. That means fewer errors equals fewer backup qubits equals smaller, cheaper, faster quantum computers, aka finally getting practical quantum machines that could, say, simulate the human brain or crack unbreakable codes. Now, before we break out the champagne and sparkling apple cider, there's still work to do. This breakthrough was for single qubit gates, but 2-qubit gates, where qubits interact, still have higher error rates, around 1 in 2000. Oxford crushed solo mode, but next up is multiplayer. So what does all this mean for you? For now, it's a flex for physicists, but down the road, this kind of precision could power medical breakthroughs, supercharged AI, and cybersecurity that actually sleeps at night. Thanks to Oxford, the dream of functional, error tolerant quantum computers just got a whole lot closer. And if you're still confused, don't worry. Quantum computing is basically the universe trolling classical logic, and somehow making it work. Thanks for watching, and don't forget the future is now.